today, climate change and indigenous agricultural knowledge in Sri Lanka. Today we are going to discuss climate variability and climate change. What does climate change mean in Sri Lanka? Then we discuss about ecosystems, products and services for the people who are living around. Then we talk about what is our future, what is our fate in face of climate change. And we'll have to understand the greenhouse gases and emission. Finally, we wanted to discuss about how we can relate this indigenous agricultural knowledge, how we can utilize it, how we can adapt it to face climate change. You may remember, we have traditional Sri Lanka. It is environmental friendly farming was practiced before Green Revolution. We did not use any chemical fertilizers or pesticides. Only we adapted traditional techniques where natural pesticides and natural manures obtained from plant and animal products in the past. During 1950s and 60s, the ever decreasing population of the country led to increased food requirement. This is not only for Sri Lanka. At global scale, we had to face some food scarcity because of the World War II. Then later on, there are some forecasts about long drought, famine disasters, especially in India and Africa. So that our government was forced to import food grains from foreign countries and also forced to increase the food grain production of the country to increase the food security. This is the situation that we had when we tried to get introduced Green Revolution. What are the things that we got as benefits? Increase the country's food production, attain self-sufficiency in food. Then our country converts food deficit to food surplus. Because of that, we had some opportunities to export our food products. And also, farmers got a good income for their living. And we should not forget that this particular Green Revolution has introduced improved varieties, but it needs high input cost, pest and disease control, and also those are susceptible to drought and salinity. Then we introduced mechanization to the fields, agricultural fields. It damages to soil environment, causing soil erosion. And also, along with this soil erosion, nutrient loss is taking place, water losses, insurgence of weeds. We have discussed a lot about this Green Revolution and its impact. And also inorganic fertilizer and agrochemicals. It tends to increase soil acidity, polluted with heavy metals, and faced micronutrient deficiency. Because of these chemicals, now poor microbial activity, and finally, our health problems have been experienced by people. The Green Revolution was a period during which the productivity of global agriculture increased drastically with improved technology. During this period, new fertilizers and pesticides were created. Those are specially uh, derived from fossil fuels. With increased agriculture production, including crops and livestock, contribution for greenhouse gas emission has increased. I will explain you what greenhouse gas means. At present, agriculture contributes 25% of the GHG emission. Now, we have different sources. One is energy. The other one is industries. And there's another one, agriculture, transport. All these are there to contribute to GHG emission. Our concern is agriculture. Agriculture contributes 25% of the GHG emission. That is why we have the concern on this. We'll have to understand to a certain extent what is climate change. Before we understand climate change, we want to understand climate variability because sometimes people get confused with these two terminologies. Some people misunderstood climate variability as climate change. So as you are learning in this climate change part, you have to understand the differences. Climate variability is the differences we observe in the climate from year to year. If you look at this one, you can have here temperature. Next year, it goes up like this, and it comes down like a fluctuation. So if it is happening like this, it is climate variability. If you observe for a long time, then if you get a trend of increase in something, rainfall or temperature, whatever it is, then this trend is called climate change. And also we could be able to observe these are climate extremes, either side. Okay, so this can be due to impacts of on climate from changes taking place in ocean conditions far away, such as El Nino. So this El Nino occurrence is not due to climate change. Climate variability is natural and it occurs on systematic base. So it doesn't have anything about human activities. So that is climate variability. Then what is climate variability? Refers to changes in climate from one year to the other. It can be caused by changes in ocean conditions like El Nino, as I told you. Climate variability is natural and occurs on a regular basis. Then climate change. Climate change is the change in climate over a time period from sometime 10, sometime 20, 30, or if you have data, it's about hundreds of years. So climate change involves both natural changes and changes caused by people. So that is the difference between climate variability and climate change. Climate change. Climate is the average weather at a given point and time of year over a long period, typically 30 years. That is the period that we are trying to consider when we are going to see whether there is a climate change. Then we expect the weather to change a lot from day to day. But we expect the climate to remain relatively constant. We have Maha season, intermonsoon seasons, northeast monsoon, southeast monsoon, second intermonsoon season. Like that we are expecting. But all of a sudden, we will get some other changes within that particular season. If the climate does not remain constant, we call it climate change. The key question is, what is a significant change? And this depends upon the underlying level of climate variability. So you have to understand very clearly what is climate variability, what is climate change. If somebody asks from you, you can explain it with some kind of mathematics. Crucial to understand difference between climate change and climate variability. Okay. Now, take one simple example. If you are supposed to measure heights of children in a particular school, you know that small children are there and advanced level children are there. So the height, body height is different. So that if how you can summarize the results of this body heights. So body heights change from one class to the other class or within the class, like that. So that what we can do, we will take all these people, all these students, and we take different ranges. For example, 3.5 to 4, 4.5 to 3.5 to 4, 4 to 4.5 feet, 4.5 feet to 5, and from 5 to 5.5, etc. Then we have different ranges. What we can do, how many children under one range, how many children in the other range. So we will calculate them, and you can easily understand if you can convert that into percentage. Take the whole students population is 100. What is the percentage of children is having a particular height? Like this. So we have average height, we call mean, or in scientific sense, we call median. And we will see that the percentage is decreasing here and also decreasing there, right? This is the example we use, how we can explain climate change. Now here, look at this sun. This is, if there's any kind of parameter, here you get, this is the normal distribution, right? So when we have another population after about another 20 years, if you plot it, you will get another normal distribution curve. What it means? Now here, you get a mean in the past 20 years, you get another mean here in the present 20 years. That means there's a shift in mean or median. It says that the climate change is taking place. That is one. The other one is normal distribution, mean is same. Mean is same. But this is the first 20 years normal distribution. This is the second 20 years normal distribution. What happened? Here the mean is here the same, but the percentage distribution is different. We call that is standard deviation. So here standard deviation is same. Here standard deviation is different. Now we have two parameters. One is mean. The other one is standard deviation. So if you look at this third one, Here, mean is 15 here. And standard deviation is 6. Okay. Second one, you get a shift here. Mean is 30. It changes from 15 to 30. And now it's like this. So the standard deviation is small. We have only 3. This is a simple illustration. You try to understand now, or later if you go through this one, you may be able to understand. So this is the extreme temperatures we have. This is from IPCC, Intergovernmental Panel on Climate Change. They have described this shift of mean and shift of standard deviation. If it happens sometime both, so we call climate change. Before that analysis, so many people tried to see how this temperature, global temperature varies. Now up to this one, this is the average, right? Average of over this total period. So average here lower than the average. And you will get above average, below average, above average, below average. Finally, there is a trend here, above average. That means now we are getting experience of high global temperature. And they wanted to plot it and relate. What about the carbon dioxide concentration? Carbon dioxide has been considered as greenhouse gas. So it tends to increase in the atmosphere. And finally, we have a sudden increase like this. So it is something related to temperature increase. Here, this is seawater rise, global sea level rise. They calculated from 1990 up to 2005. They got all these plotted, and finally there is a trend like this. So this trend is attributed to 2 factors. One is because of the temperature rise, ocean water can be expanded. We know that is very, very obvious, right? The other one is that because of the high temperature, increased temperature, glaciers can be melted. The contribution of this expansion is 60%. Contribution from melting glaciers is 40%. You can see this is very high and distinct compared to this. Climate change in Sri Lanka, what we observed that the number of rainy days has decreased, except in Nuwara. The total annual rainfall has not decreased in many areas. Annual rainfall variability has increased. This is variability has increased. If you get variability is increased, that means it's a climate change. Then annual mean air temperature is increasing. Then we get extreme events because of short duration, intensive rainfalls. You get flood, and at the same time during other periods, drought. So that those are the climate change situation and the impact of greenhouse gas emission on climate. This is Anuradhapura and Ratnapura. Now, when you plot these all rainfalls, I don't think that you can see any kind of trend. Even in Ratnapura, you don't see any kind of trend. This is Mahailuppalam. We have plotted this one, and we did not find any kind of trends here just by plotting average rainfalls or annual rainfalls for the period of this 1905 to 2005. So what we did that, we could be able to plot this. This is uh, one about 30 years, I think. This another 30 years. So difference is, you can see that these are the high rainfall phases. Here also high. This is the lowest rainfall phases. If you look at these, the differences, it has expanded here. This has shrinked here. So that is due to climate change. And also, if you just take probability statement, again 1905 to 2005, we calculated the probability values during different 20-year periods. Different 20-year periods, right? So this 20-year period, if you just calculated 75% probability, it is very high. And if this here, you get a very low amount of rainfall at that 75% probability. So what we can tell that this is for the major rainy season, the Maha season. So if somebody is like agriculture instructor who was in that particular period, he will say, he will ask farmers to, with that statement that you are getting about 840 millimeter rainfalls. Now, the present agriculture instructors cannot say that. They say that now you are getting a very, very low rainfall at 75% probability. So that we have the high time to think about how we can face this climate change. There are causes, there are factors. One is changes in land use, right? Earlier we had a good percentage of forest, now it is declined for farming and for building cities. The storage and use of water. We have constructed dams, reservoirs for irrigation purposes. Then combustion of fossil fuels. Because of this, it generates heat. It generates particulate pollution, soot and smoke. It generates gases pollution, sulfur dioxide, nitrogen dioxide, and get oxidized to form sulfate nitrate. And it generates carbon dioxide. Now you can see that there are some undesirable gases are coming and mixing in atmosphere. So we have decided at global scale, there are greenhouse gases. One is carbon dioxide, yes, it is obvious. Then methane, nitrous oxide, then chlorofluorocarbons. Especially it goes for ocean layers, burning, landfills, rice paddies, agriculture, animal husbandry. So many factors are affecting this greenhouse gas emission. And also, there are changes, composition of the atmosphere because of these greenhouse gases. Now, why we are not ignoring the effect of carbon dioxide? Because once carbon dioxide gases emits to atmosphere, it will last for about more than 100 years, right? So we will see the relative lifetimes of these. Then rise in greenhouse gas emission has caused to become drier dry areas become more dry and wet areas are becoming wetter. During with how to save in times of excess or times of drought, that is our challenge. Now we don't have always same amount of rainfall, same amount of storage. So we'll have to save the storage for dry seasons. Food production needs to double to meet the needs of an additional 3 billion people in the next 30 years. Climate change is projected to decrease agricultural productivity in the tropic and subtropics. One way, we need to produce more and more food. The other way, that agricultural productivity has decreased, especially in tropics and subtropics. Then there's another prediction. Source of fuel for 1/3 of the world's population is fuel wood. That means wood demand will be double in next 15 years, 50 years. Climate change is projected to increase forest productivity, but forest management will become more difficult because it will be affected with pests and fires. Climate change is projected to decrease water availability in many arid and semi-arid areas. Right? 1/3 of the world's population is now subject to water scarcity. That will be increased during next 30 years. Population facing water scarcity will be more than double during next 30 years. So that is the challenge we have. We have to understand that. Then what about biodiversity? Biodiversity underlies all ecological goods and services. And next 10 to 15 years, estimated 10 to 15% of the world's species could become extinct over the next 30 years. So sudden increase of climate change will cause losing our biodiversity. The challenge, some people argue that we call sustainable development, sustainable management. They will question back how you can think of sustainable management of an ever-changing planet because of climate change. It's changing. So there are lands, wood and fiber production, provision of clean and sufficient water, maintenance of biodiversity, maintenance of human health, storage and cycling of carbon, nitrogen, phosphorus. So these are from biodiversity, but the problem is climate change will affect the ability of ecological systems to provide essential ecological goods and services or products and services. We'll have to learn something about ecosystems. The ecosystem products are food, then fuel wood, then non-timber forest products, fisheries products, marine products, wetland products, medicinal and biomedical products, forage and agricultural products, water, reeds for weaving mats, then building materials. All these are services which will provide will be provided by the nature in an ecosystem. Functions and services. There are services, hydrological services. It can purify water. It can capture, store, and release surface and groundwater. It can mitigate floods and droughts. Biodiversity. It can maintain biodiversity. The biodiversity means both plants and animals. Then climate, partial stabilization of climate through carbon sequestration. Now we will be able to learn something, how we can mitigate the greenhouse gas emission. And also, because we have a lot of greenhouse gases emission in the atmosphere, at least can we reduce carbon dioxide from the atmosphere? That is called carbon sequestration. Because of the vegetation, carbon dioxide can be absorbed into this vegetation and later on into soil. Moderation of temperature extremes and the force of winds and waves due to microclimate effect in these ecosystems. When you look at ecosystem services, there are four. One is provisioning services. It can be provided for human beings. Regulating services. It can regulate some kind of problem in the surrounding. Then cultural services. The other one is supporting services. If anybody asks, what are the ecosystem services? You can explain four components. One is provisioning services, regulating services, cultural services, and supporting services. Out of these four, this one is something different because it supports to keep the ecosystem sustainable by regenerating the fertility like that. Recycling some elements, sulfur, carbon, water, etc. So here, now in these rural areas, you get cottage industry. That is materials from Kattakadu, consumables, food, fruits, vegetables from Kattakadu, Gaskommana and Pava. These are provisional services. Materials, timber, fuel wood, farm implement, household implement. So the ecosystem can provide something to human being. Others, sometimes medicine, biopesticide, animal feed, etc. And regulating services. Now, you are familiar with this traditional system of tank villages. It can regulate drought. It can minimize the impact of drought by water storage, reduce seepage and evaporation, and it can produce clean water. Flood. It can minimize the impact of flood. Rainwater absorption, excess water drainage, flow regulatory mechanism. In this particular system, if you are interested to know more about this, please follow my links. I have given 5 links so that you can read a lot. Then cyclone you can have here because of this vegetation and large trees in Gaskommana, Kattakadu and Tisbambe, here Tisbambe, and the forest, so that it will mitigate the impact of cyclone. Then epidemics. Malaria, water purification, waste recycling. Because of this, water-based diseases can be reduced by having this kind of environment. So that is regulatory mechanism. Then supporting, how the environment can support itself to ensure the sustainability of the ecosystem. For example, here, meat tree, and it attracts bats, right? Bats will provide bat dance, and it will make the soil fertile, and it will encourage the growth of this meat tree. So that they are a way of having this sun. So those are the things that we call supporting services. Nutrients, Tisbambe, Gangoda, Landa, meat tree, and habitats. So it can provide habitats for a lot of animals. Kattakadu, Gaskommana, Perahana, Vevtavula. So you read where these components are located in this. And cultural services. How do you make your society? How do you make your whole community peaceful and enjoyable one? Recreation and mental and physical health can be received from agricultural landscapes, recreational opportunities. That is one recreation. And also aesthetic beauty, aesthetic appreciation and inspiration for culture, art, and designs. Then spiritual experience and sense of place, natural heritage, spiritual sense of belonging, traditional knowledge, and associated custom. Not only that, now we have some other opportunities to market this particular system to tourists. So the tourism is getting its advantages in this particular system. So there are studies we have conducted to know what kind of services that the ecosystem can provide you. So provisional services, paddy and other cereals, legumes and other seed crops, leafy vegetables. If you go to a kattakadu, you will find all these vegetables and tuber crops, clean fresh water in the tank for drinking and domestic use, irrigation water, inland fishery, livestock, fodder and grasses, sedges and other alternative plants, herbals, medicinal plants, and materials. And also, it provides opportunities and environment for ecotourism. And ecosystem services, regulatory services. So we have done a study, especially with some scientists from Wyoming University. We did it in Mallathuve Basin. We found that it can control floods and flood protection, groundwater recharge and flow maintenance, water purification, local and global climate regulation, pollination, soil nutrient and erosion regulation. So that these are the controlling services or regulatory services. Then here, it can ensure food and nutrient security. And also it can ensure biodiversity conservation and maintenance. We have drawn up some recommendations from this study. One is policies and regulations are required. At present, we don't have a good adequate policies to conserve biodiversity and sustainable use interventions. Second one, interventions should be done to conserve and restore the village tanks with the involvement of multi-stakeholders, because one cannot do it because of the institutes we have for different aspects should sit together and discuss and make the plan. And also the knowledge transmission, farmer awareness and provision of necessary technical and infrastructure support. So farmers are the final stakeholders, right? They wanted to know what's happening and they can understand what is this biodiversity, what is this biodiversity decline, what is this climate change, because of climate change, what will happen to our ecosystems, everything. Then plan and implement programs which promote the traditional and indigenous knowledge in their food production systems, because still we appreciate, we respect the traditional and indigenous knowledge we had in the past, and it is still there for a certain extent. So we'll have to utilize this to plan and implement our programs. Then conduct research to mainstream indigenous knowledge in conserving and popularizing the traditional land races that will result in implementing effective adaptation action on the ground. So that we should not forget about our early varieties, especially we call land races, so that it can be utilized uh, to breed improved varieties which are uh, tolerant to these climate shocks. That is what we need. Then provide farmers necessary awareness and inputs to enhance popularity of organic and locally grown food. Programs should be carried out to build knowledge and understanding of native agriculture and food systems and help promote native communities, innovative ideas, and best practices. If you are having any kind of idea to do some research, this is a very nice recommendation you will get, because that you have to study further and make your own recommendations. Promotion of local traditional agriculture and local cuisines can be used to promote agritourism, ecotourism, and cultural services. The 10th one, action has to be taken to provide access to better medical facilities to vulnerable groups such as elderly adults and school children, and awareness and behavioral change communication actions must be taken. So, under that circumstances, because of the climate change, what will be our fate, or what will be our future? Flood is there, drought is there, epidemics are there, so many things. Our environment is severely polluted. Roughly 50% of its 22 million citizens live in low-lying coastal areas in the west, south, and southwest of the island, and are at risk of future sea level rise. So you can see that half of our population is something associated with income generation activities in the coastal border. So that if there is any tendency to have sea level rise, it will affect these people. Climate change also threatens the island biodiversity, including its marine ecosystem and coastal coral reef environments. Now we are having a very bad uh, results of these studies done in this coastal border, that coral reef environment is severely affected. And it affects agricultural productivity, causing natural disasters like floods and droughts, increasing the spread of infectious illness, and finally undermining the living standards. That means poverty. Now, changes of weather fronts. As we explained, dry regions become more dry. Drought frequency may increase, delayed southwest monsoon and short duration southwest monsoon. When you have short duration intensive rains, uh, it will lead to flood, and also it will lead to landslides. Intensity of drought may increase a long dry spells in wet season, even wet season. Marked increase in interannual seasonal variability. So, interannual seasonal variability we have observed. And One unfortunate thing is that because of the temperature, high temperature, increase in evapotranspiration. So high water loss from open water bodies. Enhance the drought condition in minor tank cascades in Sri Lanka. High surface area over depth ratio, hence more vulnerable. Now you can understand in these minor tank systems why these tanks go dry fast because of its shallowness of the water body. And also it does not have the now that ecosystem around the tank water body. So that it is now open. So more and more evaporation, seepage are taking place. Then high variability in seasonal rainfall, high variability of monsoons, strong persistence and frequent El Nino events, intense rains, strong tendency for above normal. Now we are talking about new normal, above normal. So we are not expecting normal now. Then increased frequency of floods and droughts affect. It affects agriculture, it affects water resources, it affects infrastructure. Now we have to come to the problem of soil erosion. As you expect that soil erosion is taking place in central highlands, it's not true because all over the country we are observing soil erosion at different levels. It's not just the amount of soil that will be eroded. It is the fertility decline. It is the land degradation. So some soils are very sensitive for this soil erosion. Now, steep slopes are highly vulnerable. Siltation of reservoirs. For example, now we have given some examples here. Polgolla, Rantambe, Victoria, even minor tanks, the rate is very high, 2.4% per year. So one is soil erosion from the site. The other one is tank sedimentation, reservoir sedimentation in the low part. So we will get a lot of marginal lands due to land degradation. That means soil productivity will reduce. Especially now we are talking about mid-country tea lands. Average soil erosion in Upper Mahavali is 115 metric tons per hectare per year. But remember, soil formation is very, very, very slow. It is 1 centimeter during 100 to 400 years. You can imagine what will happen to us when we allow this soils to erode. Then change in rainfall regimes, high intense rains. If daily rainfall exceeds 200 millimeter per day, there's a high probability of landslides in prone areas. That is one of the criteria using National Building Research Organization, NBRO. They estimated 12,500 hectares are now under the threat of landslides. Sea level rise. Coastal zone of Sri Lanka, approximately 24% of the land area and 32% of the population. Directly in coastal areas. But adjoining areas also people are living and they will also be affected due to sea level rise because it's get flooding. 65% of urbanized land area, the 80% of tourism, 65% of industrial output, commercial ports and fishery harbors, principal road and trail infrastructure, then some important ecosystems also in this coastal belt due to sea level rise. All of these uh, things are happening, affecting tourism, then land, industries, commercial ports, etc. So, our fate is climate change adaptation projects of building resilience. Sri Lanka is presented with strategies to help lessen the effects of climate change in the vulnerable communities. So it was suggested that Sri Lanka should increase non-agriculture jobs by 30%, enhance the level of education, and reduce the time to reach the market. This is what government thinks now to get away from agriculture. Our logic is, our argument is, can't we use traditional knowledge experience as a climate change adaptation strategy? This is the whole crux of our all these lessons, right? Greenhouse gas. A greenhouse gas is any gas causing the greenhouse effect, right? So we have different gases. For example, methane. Methane is a greenhouse gas. Water vapor, that's also a greenhouse gas. Nitrous oxide, that's a greenhouse gas. Carbon dioxide, greenhouse gas. But generally, we don't consider water vapor is that much effective in this climate change because those have lifetimes for different one. Water 10 days. Within 10 days, it goes out and it will be broken into other elements. Carbon dioxide, generally 100 years, but it will range from 5 to 200 years, right? Then methane. Methane is 10 years. Nitrous oxide, 115 years. Then hydrofluorocarbon, one is 1 to 250 years, the range. Other fluorinated gases, higher than 2,500 years. So you can see the lifetime is different. But again, the same, when you get very high lifetime, the percentage of these gases are low. Nitrous oxide 6%, fluorinated gases 2%, methane 16%, but carbon dioxide 76%. So we are worried about this carbon dioxide storage in the atmosphere. Not all others, but we have to think about carbon dioxide, methane, nitrous oxide, especially. Now, this is the greenhouse gas effect. When you have radiation, it comes to the earth. Part of that in the space will be reflected back out to space. Then once it comes to the earth's surface, it will cause warming the globe and some radiations are going back to the space. But because of the greenhouse gases, part of that will come back to the earth. Then it warms up the earth surface. So this is greenhouse gas effect. Greenhouse effect, right? Do you have any question on this? When you take greenhouse, where we are going to plant for experiments and for even production, we have a transparent roof through which the sunlight will come. Once it comes, it increases the temperature within the greenhouse gas, within the greenhouse, right? So that the radiation back out of the greenhouse is so minimum, so that it will cause increase in the temperature within the greenhouse. That is what is happening in this at global scale. It's called the greenhouse gas effect. So these are the greenhouse gases, main greenhouse gases we are talking about. One is carbon dioxide. Especially it emits from fossil fuel. We know we are using fossil fuel for different things, transport, industries. Then carbon dioxide can also be emitted from direct human-induced impacts on forestry and other land use, such as through deforestation, burning this land clearing, and degradation of soils. So many things. Methane, for different agricultural activities, it emits methane, especially paddy fields. Waste management, energy use, and biomass burning all contribute to methane emission, including livestock. The nitrous oxide, agricultural activities such as fertilizer use are the primary source of nitrous oxide emission. Fossil fuel combustion also generates N2O. In addition to that, N2O can be emitted through manure management. You know that in cattle sheds, you get a lot of manure, cow dung, and the residuals of their feed. So that it will be heated up somewhere, and with the moisture and the temperature, it will emit even nitrous oxide. Then others are industrial processes, these fluorinated gases, refrigeration, and the use of a variety of consumer products contribute to emission of fluorinated gases. This is very, very minute part, but still it is taking place. In Sri Lanka, as I told you, agriculture, we are concerned about agriculture because agriculture contributes about 25% one to the greenhouse gas emission total in Sri Lanka. Energy 61.5, industrial processing 2.6, waste management 10.8. Now, how we get these greenhouse gases from agriculture? One is rice cultivation. You can see rice cultivation 52.4 here. Especially rice straws, paddy straws. Then the other one, 26.6, enteric fermentation from livestock. Then although you expect a big contribution from burning of crop residues, that is only 1%. Then manure management, 3.9. And there are some soils, we call peat soils sometimes, but we do cultivation. There cultivation of organic soils, it will contribute 16.1. So that where we have to address. One is paddy cultivation, the other one is enteric fermentation and manure management. Okay. Generally in agriculture, manure will emit nitrous oxide and methane. Rice cultivation, methane. This is main GHGs, greenhouse gases. Enteric fermentation, methane. Burning of crop residues, carbon dioxide and nitrous oxide. Cultivation of organic soils, methane. You can see the diagram. Now people are looking for how we can mitigate these problems. One is that we have a lot of greenhouse gases in the atmosphere, right? Especially carbon dioxide. But carbon dioxide can be absorbed by the vegetation, right? So one way of reducing greenhouse gas emission into the atmosphere, the other one is whatever you have in the atmosphere can be absorbed by vegetation. So we call two things. One is GHG emission reduction. The other one is carbon sequestration. Here you can see all these sources will emit carbon dioxide, nitrous oxide, and methane. What we will get here sometime soil carbon, right? In this soil carbon, we call, coming into this process is called carbon sequestration. So two things. One is that reduce GHG emission, encourage carbon sequestration. So what are the strategies we have? How we can reduce methane? Methane from livestock. We can improve feed quality, extend lactation periods of dairy cows, use more efficient breeds, improve reproductive performance, and increase rates of gain in beef animals so they reach the market sooner. Uh, Now, this methane emission can be reduced in livestock. One thing that enteric fermentation has to be reduced by fast digestion. Fast digestion. So, lactation period, if you can improve, then the body attempts to digest the feed fast. Then the other one is use more efficient breeds to increase the digestion. Especially, they found that this foreign breeds, improved breeds, do not encourage reduction of methane. But local one has the potential of reducing methane. So that now we have to go back to the traditional systems. The nitrous oxide reduction. We can adjust fertilizer rates to coincide with plant needs rather than just spreading everywhere every time. Place fertilizer near plant roots, but not too deep in the soil. Apply fertilizer several times each year rather than only once using slow release forms. So whenever you do application of fertilizer, you have to be very careful. Efficient consumption of fertilizer in the plant. Greater use of legumes as a nitrogen source, use of cover crops in place of chemical fertilizer. So we can remove excess available nitrogen, avoiding use of summer fallow, leaving the land unplanted with no crop nitrogen uptake for a season, and adjusting tillage intensity sometimes, but not always. No-till practices can reduce emissions. Now, just apply this on to our local farming. In paddy cultivation, you have fallow periods. Sometime in under minor tanks, you have more than 5 months fallow. If farmers to practice Jala and Maha cultivation, still there are tendency of having 2 to 3 fallow periods. So these fallow periods can you utilize to make a green cover to absorb carbon dioxide more and more and encourage carbon sequestration. That is our argument. Then alternatives to chemical fertilizer. Can we do, instead of applying chemical fertilizer, can we apply organic fertilizer? Some alternatives like farmyard manure and compost. Promote slow controlled nitrogen reducing fertilizers and increasing their effectiveness. Deep placement and reduction of frequency of application of nitrogen fertilizer. Use of, that means if you can try your best to reduce the losses of chemical fertilizer and efficient use of chemical fertilizer should be ensured. Then otherwise, what will happen? It will be in the soil or on the surface, which will emit the GHG, greenhouse gases. Emission from enteric fermentation, rice straw. Rice has low nutrient properties, low bulk density, and not suitable for fertilizer due to high CN ratio. Now, up to now, Department of Agriculture recommends don't burn rice straw. You put into soil, mix it. But the problem is when you mix it in muddy field, it will emit methane. So that now the recommendation has to be changed. Then organic farming, then there are some other uh, concepts like evergreen agroecosystem concept or agroforestry. Biochar as a suitable soil amendment that can increase soil fertility. And conservation farming, conservation farming, you must be learned about conservation agriculture, reduced tillage, contour farming, terracing and non-tillage. I think you have one course for conservation agriculture, and we have done research for about 15 years at Mahiluppalam, so that there are a lot of recommendations emerge from these research programs. Livestock farming. One is feed in efficiency to get digested soon has been found to reduce methane emission and increase milk production. Then enzymes, when you mix it enzymes, then it will be digested soon. And adaptive measures on livestock housing, mainly to tackle high temperatures, are introduced and are successful operational within the country. So animals, cattle and buffalo and all, need some kind of comfort. Comfort means they need a shade. So people are now trying, even from through some projects, they are trying to provide sheds, cattle sheds. But in the traditional agriculture, traditional knowledge, right, this is inbuilt. They have their own shade environment under different trees. So they can roam here and there, and they can rest under trees. They can drink water from the tank. So as you learned that we have different roaming areas, Gasgommana, Pirahana, Kattakadu, and sometimes paddy fields during the fallow periods, Chena lands during fallow period of the Chena, like that. Warm climate does not allow temperate breeds to perform well, but the local breeds adapted to those conditions and produce less milk. Now, the problem is there. One is local breeds cannot produce a high amount of milk. Their yields are low. The other way, it can uh, tolerate a warm climate. So what they suggest now, mid and up country of Sri Lanka have a favorable climate for top producing animals, but land availability is low. So that they wanted now to uh, move to dry zone where we have enough lands so that they can rear local breeds. Number of local breeds can be increased. There's a way to construct farmhouses by tackling high heat. To accommodate more air movement, most farms consider well-ventilated high roof sheds. Generally, they want high roof sheds. And a few have introduced cooling and fogging systems. Now, forget about all these artificial things. Why don't you have some natural environment to make them happy with good comfort? Improved cattle breeds are typically given higher quality concentrate feed, mostly consisting of coconut cake and rice bran, and that they have higher digestive efficiencies with reduced methane emissions. So that is also possible because improved cattle breeds can be fed by fast digestion mixture of feed. Supplementation with fodder trees, rice straw, and low-cost concentrate. Here, lower methane observed with legumes is attributed to lower fiber content and faster rate of passage of feed through the rumen. Thus, intakes are higher with legume forage. When you add legumes like Glycidia, it can be digested fast. So that fast digestion means low emission of methane. Use of total mixed ration improves productivity and reduce methane emissions. Supplementation of forage diet with Gisedia blocks promote high dry matter intake, can have a faster rate of passage through rumen and reduce methane. Then animal comfort, we have discussed about that. But low quality forage, including grasses, causes high amount of methane. This is the problem because now we have promoted farmers, encourage farmers to do a lot of grass species. But if it is only grass species, that is not good because we have to mix it with legume parts of the trees. Then that is one, reduce greenhouse gas emission. The other one is how we can increase carbon sequestration. Tillage should be reduced, degraded land and improving past management to be restored, reducing fallow periods, as I told you earlier, adding animal manures to the soil, crop residue management, because otherwise it will emit methane, and also sometime in some places even nitrous oxide, because you are getting some mixture of cow dung and feed residues. Using legumes and or grasses in crop rotation, converting marginal cropland to perennial grass or trees. This is something important because if you have, the policy should support, if it is a marginal land, it is not good to keep exposed every season. Instead of that, you can go for perennial grass or trees. Using rotational grazing and high-intensity short duration grazing. Planting shrubs and trees as shelter belts, and you can restore wetlands. And in case of home gardens, we have done a small calculation. And what we did that, here you get some low value in 2023, very low value, because we have average one, maximum one, and minimum one. So what we have to do, one step is to minimum to average. Second step is to from average to maximum. So every home garden has that maximum level, so that we can have by the year 2050, we can have a very good contribution of carbon sequestration from home gardens, dry zone home gardens, wet zone home gardens, and even intermediate home gardens. So this is a very good strategy that we have included this one for the roadmap of net carbon balance. Then climate change. And we can compare the with traditional knowledge, right? One is temperature. According to climate change, dry seasons become more dry, high water loss from open water bodies. But these are not the usual things that we can observe in these traditional tank village systems. Rainfall, high variability in seasonal rainfall, increased frequency of floods and droughts effect. Those can be absorbed by this system. Problem of soil erosion. Steep slopes are highly vulnerable. Siltation of reservoirs, land degradation in marginal lands. Now, these are happening now. Because of that, tanks are silted and shallow water bodies, evaporation is very high, so that it is getting into a disaster situation. So what we have to do, it is very, very clear that we have to restore these ecosystems. That is traditional knowledge. Now here, when you have that traditional tank, you can have 4 phases. Here the sluice. Below the sluice, we have storage here that cannot be moved through sluice. That is called dead storage. Second one is deep phase here. Then shallow phase here. And when it spills, you get spilling phase. So there are 4 phases. Why we want to talk about this? Because they have a very advanced management of tank water. They don't allow people to get water during Maha season below this one. So this is for Yala season. Okay, so they can cultivate Yala and Maha season. How we can do it? Because during Maha season, they can use a lot of rainfalls. So that tank water is utilized in minimum levels. This is the boundary that somebody can think of, because then you can utilize this water only for Maha season, and this will be left for Jala season, right? But dead storage is there not to irrigate, but to keep the environment moist and ensure the sustainability of vegetation around. This is traditional vision of water management. Now we talk about, sometime you may know, integrated water management approach. What are these integrated water management approach? One is rainwater. The other one is irrigation water or tank water. Third one is groundwater. But in the past, people have utilized all these 3 sources. Whenever you don't have rainfall, they will use even groundwater like this, because generally paddy fields are with low humic clay soils, which are clayey, and it can become saturated when the water table comes just within this 50 centimeter, so that it can facilitate the growth of these paddy fields. If it is not there, then you have to think about tank water. You don't want to think about tank water or groundwater when it's raining. So that is integration. Then we have done some experiments in 1990s. We found that a lot of small tanks have been sedimented, and the water body is so shallow, evaporation is very high, so that under such situation, we cannot face the climate change. So what we can do, this dead storage, Mandakalu, Diagilma, Tawal, and Wangilma, those are the terms that they have used. This sediment, what we are going to do? We found that during from 1970 to 2005, a lot of projects have come to develop agriculture in the dry zone. They have renovated, they have rehabilitated tanks. They have supplied good irrigation water at the maximum level. They have facilitated agriculture. Everything they have done. But you can see, this is cropping intensity, how it varies, how it fluctuates, right? To me, it is like it goes in harmony with rainfall only. So what happened of these results of consequences of rehabilitation programs? That is why we say that there's a problem. So the problem is cropping intensity is does not exceed even 1. It's always somewhere here. Probability is 70 somewhere. You get about 0.5 cropping intensity. So this is the problem. Why we get this problem? Reduces water use efficiency due to increased tank water losses. That is one. Disappearance of the tree strip, Gaskommana, then Perahana. This would enhance the water evaporation due to advection effect. Then, development of salinity in the upstream area around full supply level, especially if the tank is second or third in the series. Inundation of upstream rice fields, it can destroy the rice crop in the upper part. Disappearance of some fish species which cannot survive in shallow waters. You know the reason of disappearance of lot of our local fish species is not that we have introduced some uh, imported species, not that one, at least because I have an argument because these local fish species are carnivorous. Those are not herbivorous. So carnivorous species introduce again carnivorous species so that these two live together. That is coexistence. For thousands of years, these carnivorous fish species, about 35 species, they have lived together in harmony with the nature. You see, these are very important fish species which will get extinct very soon. This is snake head, and this is corally, petia, this is lula, this is aada, and here you get valea, and this is hunga. So these species are especially our rural villages are still remember to use it, but they say that those are not in the tank now. Okay, look at this one. Taking these different tanks, we establish tank water losses and some other parameters. Capacity over area. When you say volume divided by area, you will get a height. So this will tell you the average height of the water body. When you get average height of the water body, right? Average height of water body is, percent water loss is high here. When you get average capacity over area is somewhere around 1.3. So this is the relationship. Then when you get a higher one, you will get water losses higher. So this particular message we have utilized to sedimentation and we called desiltation. That is called partial desiltation. We have introduced in 1994. Yes. But now, after about 30 years, still, I know that Department of Agrarian Development is taking place, utilizing this message, but not Irrigation Department. That is the unfortunate case. Now, when you look at this one, we have done a project, partial desilting, heap up some mounds here, mounds here. You look at these mounds, and finally it will be covered with vegetation. You will see like this. So that the geometry has been changed, evaporation is reduced, and for a certain extent, they have reserved some upper lands which can be utilized for some other purposes. This weather forecasting, you have learned this weather forecasting in one. So this weather forecasting still valid. It comes from animals. Then the environmental observation, trees, cloud, moon, etc. Signals from wind, temperature, and humidity. Long-term experience passing from generation to generation. So this weather forecasting systems still can be utilized. Even they now also they utilize this weather forecasting systems. You might have had this opportunity to learn about in one previous lecture. Sorry. Now we can, sorry, I am suffering from bad cold. Betma practice during drought periods. Betma is division. Now redistributes plots irrespective of the ownership. Because of the drought, we have to have some small parcels of lands to cultivate with the available water in the tank during drought period. That is Betma. Then it will give some yields just for the survival. Then Pangu is when you get prediction from weather forecast, if these farmers believe that there are heavy rains coming in the future, then they use repairing of all these things using Pangu method. Calculum is the dry sowing. Dry sowing just with the onset of rains and mix it with soil, and it can capture all the rainfalls in the Maha season. So that is the advantage of calculum, right? So you can read all these. One study that showed that when you delay the cultivation, this is calculum in October. If you delay it, you are reducing the rainfall use and you need more and more irrigation. Because of that, it is not efficient way of using water resources. Thaul Goitan is tank bed cultivation still practiced in Mana area, Mana district, especially under the command of giant tank. But now that is banned by the government. Thaul Goitan is the tank bed cultivation because of the water is limited and they have master bund across the tank bed and they will collect whatever that the season provides them with this water and because of they did not practice this master bonding, many tanks are affected with heavy siltation. So that government tends to ban this Tawul Govitan. But still, if you just follow all these methods to protect the tank bed from sedimentation, so this is a very, very effective one. And indigenous rice varieties. Now, 1,506 rice varieties have been listed by Professor Ginigaddara in 2015. 2,442 land areas are conserved in PGRC, Gannoru. The rice varieties are meant for different purposes. Why? That is why this particular traditional local varieties are important. One is it has the medicinal value, nutritional value, and also it can be grown under various abiotic stress conditions. Some varieties improve the immunity level of consumers. These are the most important part, why we wanted to go back to these traditional varieties. So we have discussed about this importance of these varieties. You can read the links. This Hatadavi is the shortage variety which can be utilized for drought. Pokkal is to saline conditions. Pokkali Kaluhinati and Madatavalu perform well under coastal salinity. Average yield 70 bushels per acre. That is the problem. Now, these local varieties will not give very high yields. Variety suits to flood condition, Mahamavi, and the drought-resistant varieties, Nianvi, Podi Nianvi, Kolanathivi, Alvi, Mada Alvi, Magodal, like this, you can select according to the conditions that prevails in that particular area. Now the problem comes, how we can feed our nation. One is, as I shown you, in minor tank system, propane intensity is always below 1 or somewhere around. Can we increase the propane intensity up to 2 by conserving water? The other one is consumption. Now, people cannot consume this local rice, right? Not much, but all other varieties we are using, we have to eat much. So to feed the nation, the national production requirement is getting low and low if we are using local rice varieties. That is the argument. Then we have some other water management systems. One is Karahankote, the other one is Katahoro and Diegatapahana. These are very, very efficient, high-tech devices we have introduced, we have innovated in our island. Then without irrigation, we can use groundwater, pool drain. That is what we explained earlier. Shallow ploughing using traditional plough that will not pierce the hard pan, and it will save water, also nutrients, and also it will reduce the weed growth. So many things are there. You can read and understand more and more, because this is a limited time for our lectures, so that you have to do some additional reading. This is Karahankote. The wisdom here that you have different cuts. When you open the sluice, water will flow through this one, and through this one, but different volumes, different velocity, different flow. Why they want to have these different flows? Because this will feed, for example, 5 acres, this will feed 10 acres, this will feed 25 acres. So that because of the flow differences, when you open the sluice, it will flow to all these land plots. And once you close it, all these land plots, the requirements are met. That is the wisdom of this Karahankote. Here, this is Katahoro. One by one, you can use Kata. This is the piece of water which will flow into that one layer of water. That is the volume. So Kata is that particular volume. So it varies with the depth. If you go down the depth, it will be smaller than what you get here. So that they wanted to measure by using some marks in these natural rocks. It is called Diegatapahana. Now, this very popular word, Diegatapahana, in drama, and that is Diegatapahana. So many tanks still you can see. When you go to Alistana, you will see this Diegatapahana. And this is another important one, Sinhala Nagula or local plough. It can pierce only about 4 to 6 inches, right? Once it goes down to that one, it will float. That is the scientific nature of this plough. And this is not that one. This will pierce about 10 to 12 inches. So that the hard pan is broken here. We can maintain hard pan here about 6 inches deep so that it will conserve water, it will conserve nutrients, and weed growth can be regulated. But now this happened, this damage all these cultivation mechanism. Then irrigation, poorly drained area can be cultivated because it is saturated with shallow water table. But groundnut table, when it rises to 50 centimeter soil layer in most of the months, it will be supported with the high tank water level. So irrigation water is only required during the period of no rains and low tank water levels. That is the description of this, how we can integrate, how they practice integrated water resource management in tank village farming systems. For food security one, we can use reverting back to non-scientific polyculture mixed cropping from scientific monoculture. That is what happened in during Green Revolution. Then polyculture is the sustainable farming system prevailed in Sri Lanka for more than 2,500 years. Now we say that this is a new word, but it has been there for thousands and thousands of years. It ensures food security by means of diet diversity, right? It's not only rice. Then diversified income generation. If one fails, other will give you some sort of results. Production stability. Production stability means it does not vary much from season to season. Minimization of risk. Low pest and disease incidences. Efficient use of labor. Intensification of production with limited natural resources and maximization of returns under low levels of technology. So what do you think that if you have all these technology in traditional environment, right? Why you want to go for more modern technology? Because of the production, right? But at the same time, we observe that we are not producing in all lands. We have enough lands. So these are the ecosystems that we found in Candium Home Garden, that is traditional one. Eco-friendly crop protection measures such as Kurlupalu, performing chems, chemkrama. Then they have used plant extracts for botanicals in pest control. So everything was there. Everything was there. So that no need to go for some other things coming from outside. We have to use it, but with some modifications according to the present situation now here in Sri Lanka. That is what we want to pass the message through the